Hello, my name is Shane Kimbrough, and I'm an astronaut living and working aboard the International Space Station. We're currently orbiting 250 miles above the Earth's surface at approximately 17,500 miles per hour. You may be wondering how it's possible for the space station to be continuously orbiting Earth. Well, today we're going to answer that question and explore centripetal force in the microgravity environment of the space station. Let's get started. Before we dive into centripetal force, it's important to look at Newton's first law of motion, which states that an object will continue moving with a constant velocity along a straight path unless acted upon by a net external force. This means that the space station will move along a straight path if it weren't for one key external force acting on it: Earth's gravitational pull. Another name for this external force is centripetal force. A centripetal force is any net force that keeps an object moving along a circular path. Gravity, in this case, is a centripetal force because it is the force that is keeping our space station moving in its circular path around Earth. All right, here's our example. We have Aki here that has an object tied to a string. It's just a yo-yo, but it's an object on the end of a string. He's going to whirl this object around, attached to the string, so that it's moving in a circular path. The string in this demonstration provides a force of tension, which is the centripetal force keeping the yo-yo revolving around Aki's hand. It's important to note that centripetal means center-seeking. Therefore, a centripetal force is a center-seeking force. Centripetal force is always directed inward, toward the center or axis of revolution. This is because it's the force of tension from the string, pulling inward, that keeps the yo-yo revolving around the axis of revolution. Now Aki's going to set the object moving in the circular path free and remove that centripetal force by releasing the string. As you saw, once the tension from the string or centripetal force was removed, the object continues to follow Newton's first law of motion. It keeps moving at a constant velocity along a straight path relative to the space station. Can you think of other examples of centripetal forces back on Earth? To learn more about centripetal force, use the corresponding classroom connection to conduct your own experiment and discover other ways centripetal forces play out in your everyday life. Thanks for exploring some physics with me today. See you again soon.